Okay, so Assalamualaikum and a very good morning. So today I'm going to explain about my pre-lab exercise, which is experiment of the distillation column. So that is prepared by me. Personally, has only been zero time. So for the first part of this pre-lab is background theory. So as we know, the distillation column is one of the equipment that being used for the separation process in some industry that can operate in two conditions, which is atmospheric pressure and vacuum pressure. So commonly there are two types of distillation column, which are batch and continuous. They also have its own special features, which I know is for to minimize the heat loss from the distillation column to surroundings. So it has bubble cap that coated by silver and has been vacuumed. So the second part is the samples will be collected at the top and bottom of the distillation column so that we can determine the behavior of the mixture. So in this distillation column, rest ring is being packed in the column to increase the contact area of the liquid and vapor. So furthermore, we can get the high purity of the product at the end of the process. So the last part, reboiler is being used to produce heat for the distillation column directly. So the objective of this experiment is the first one, we can determine the high equivalent theoretical plates of which is HTTP at the total reflux. So after we run the experiment, we get to know the high equivalent theoretical plates. So the second part where we can determine the effect of liquid and vapor loading on HETP as a reflux after we run the experiment. So after this, we can determine the effect liquid and vapor. So the third part is to operate the batch column at total reflux, and the last one is to use the mass balance calculation after getting the data. Okay, so this is the process for like flow diagram, which is PFD. So this V101 is called feed vessel, where the feed is being transferred here. So this is a P101, which is feed pump, and this part is E305, which is what we call feed preheater. So this is benzene pump. So this is the main equipment in this process, which is we call it K1, this bubble cap column. So for the reboiler, E301 is the reboiler. So the E304 is the cooler for the bottom product. So this is the condenser for the distillate, which the distillate is the vapor in the vapor phase. So after we condense it, we will collect it in the liquid phase. So this is cooler. This is also the cooler for the distillate. So these two, V102 and V103, is a product vessel. So this is bottom pump, where the bottom product is being transferred in the high velocity to the vessel. So the last, so that's all for the process flow diagram, which are PFD. So how do we run the experiment? So we have to use the procedures. So the first one, you have to make sure that the reflux is at zero position, which is total reflux at the control panel. So the second part in the PC also does, we have to set the mode in the manual mode, or we call it man. Then the heater power control need to be set at the 50%. So after that, we have to ensure that the set point temperature of the reboiler is at active 5 degrees Celsius, and the set point value also is at the active 5 degrees Celsius. So as the top column temperature sensor, which is TT113, and the bottom sensor TT102 have reached the steady state, we have to record the temperature at the trace, the top and the bottom. Then we have to collect the samples product at the top, which is valve V11 and V16, and the bottom valve V9. We have to make sure all the remaining liquid in this sampling valve are removed, which is V11 or V16 and the V9. We have after so we have to collect two product, which is bottom and distillate. So the first one, to collect the distillate sample, we have to place the beaker below the valve V11 or V16. After that, we have to set the reflux divider to the position to 1, which is total distillate. Then we have to open the V11 to collect the top sample product. After that, we have to close back the valve V11 or V16. Then we have to set the reflux divider back to original setting, which is position 0 at the total reflux. So to collect the bottom sample, we have to partially open the valve V32 to allow the sample flow through the cooler first. Then we have to close back the valve V32. And then we have to place the beaker below V9, which is the valve of the bottom product. Then open it to collect the samples. Then close back the valve. So after we collect all the samples products, we have to record the refractive index, which is Ri of the bottom of the product in the table. So we have to, after that, we have to switch off the heater. We have to wait for approximately 10 to 20 minutes to allow the distillation column to achieve the new steady state. After that, we can drain all the mixture in the top and bottom tank. So in this experiment, we have to repeat for different liquid and vapor loading actually. So just adjusting the heater power, which is our manipulated variable according to the table, which is our data. So after we have to repeat steps 1 until 8 for different MV values. So after we repeat the experiment, we have to turn off the heaters at the control panel. We have to monitor the temperature drop in the reboiler, which is TT102, until it reach 50 degrees Celsius. Then we shut down the PC and switch off the main switch in the control panel. So there are some missing data, even though we have run the experiment. So the first one is HETP, which is what we call as high equivalent theoretical plates. So the second one is the mole fraction of the feed. The mole fraction of the samples. The third part is the number of the theoretical plates, and the last one is the effective column height. So how we want to obtain the missing data? So the first one, for the high equivalent temperature theoretical plates, we have to get to know the effective column height. So after we get to know the effective column height, we will divide it by the number of the theoretical plates. So for the mole fraction, we have to know what is the moles of A. So we divided it by the total moles. For the number of theoretical plate, we have to use a Metcalfe tail method. So for the number of actual stages, we multiply it by the tray separation. So for the formula to calculate the result is the first one. For the high equivalent theoretical plates, we have to know what is the effective column height divided by the number of theoretical plates. So the second one is the mole fraction A, which is we have to know moles of A divided by total moles, and the number of theoretical plate. We have to use McCaptile method. So in this experiment, I expect that I can determine the high equivalent theoretical plates, which is HETP at total reflux. I can determine what is the effect of liquid and vapor on HETP at total reflux. I can determine what is the result by using the data collected and the formulas. And the last one, I know how to operate a batch distillation column at total reflux. So that's all for me. Thank you.